this one is mass m1, unbalanced mass at radius equals to r1, and the same mass we can represent here also at radius equals to r1, and makes an angle of theta 1 with positive of x-axis. Consider here another mass m2, radius equals to r2. Let's say that this mass at radius equals to what? r2, and the angle from this to this is theta 2, from always with respect to what? X-axis. And then we have third mass equals to m3 at radius equals to what? r3. So this one is m3 mass, and from this point to this one equals to theta 2, and radius equals to r2. And let distance between these 2 points is L1, and the distance between these 2 planes is L2. So reference plane I have taken here. So this one is L1. From this one, the another plane, transverse plane at distance equals to what? L1. And from R1 and R3, what is the perpendicular distance between transverse plane is L2. So you draw these 2 figures, are corresponding radius. So to balance all these masses, I required only 2 balanced masses. So let me show my balanced mass is somewhere here, 1 balanced mass, and other balanced mass I will attach here. So I don't know what is the mass of this. So let's say this one is MB1 mass, and this one is MB2 mass. This one is at radius equals to RB2, and this one is at radius equals to what? RB1. So in my figure, I have 2 unknowns again. So I have to show them at anywhere. So right now I don't have a space in this quadrant, so I will show 2 masses in this quadrant. So this one is called as MB1, and this one is called as MB2. The corresponding radius is RB1, corresponding radius is RB2. Now the angle is, if I start from this one and I go to this way, then this angle is theta B1, theta B2. Similarly, I can show another angle that equals to what? Theta B2. So you can represent it and you can show like this. So if I start from this one, I can show another angle, that is this one, is equals to what? Theta B. So right now, how many unknowns I have? The thing is that, another question is that, what should be this distance? And what should be this distance? So let's call this distance equals to A distance, and let's call this distance equals to B distance. So right now I have unknown equal to the distance A, the distance B, MB1, MB2, RB1, RB2, theta B1 and theta B2. So I have unknowns. So normally they will provide you data for A and B normally, and they will provide you data for RB1 and RB2. So how many unknowns are left? Effectively 4 unknowns. So effectively 4 unknowns, it means that you require minimum 4 equations. You can obtain by using sigma f equal to 0 and sigma m equals to 0. One time we can divide this into 2 quantity. This is a vector quantity and is also a vector quantity. So you can write this quantity as summation of sigma fx, and this one is summation of fy equals to 0, vector quantity. Sigma f is consist of fx and fy because I consider only 2-dimensional system. My third axis is going this way. So this one is actually z axis, this one is your y axis, and this one is your x axis. So as far as this one is concerned, this one is xy axis. If you look from this one is z, this one is y, and this one is x. Correct? And I can take the moment about x axis. So my summation of moment about x equal to 0, summation of moment about y equal to 0. So how many successful equations I can form? 4. And once I know the 4 equation, can I solve this problem very easily? That is the only key. Now sign conventions are, this value of force is positive, this value of force is positive, this value of force is negative. So only follow this concept. Okay? So make entry for table format. That will be very quick. First entry is M1. Corresponding radius is R1. Length. Now length I will right now keep as it is. Theta is equals to theta 1. So is Fx equals to centrifugal force is M into omega square multiplied by R, and if I write X, it means cos theta. Is it a cos theta component? So if the force is like this and this angle is theta, so this component is what? Cos component. And this one is what? Sine. Omega will not write because omega is same value for all. Is okay? So we just write M1 R1 cos theta 1. Then I write second value equals to what? M R2. This is theta 2. So I can write M2. Third value I will write as M3. Theta 3. M3 R3 cos theta 3. And this column you have to fill up in sine form. So this one is M1 R1 sine of theta 1. I am holding moment. Whatever the plane you are taken, you take that as a reference plane, either on this side or either on this side, any one side. So this one is reference plane. Reference plane means all distance are measured with respect to this plane. So this is the reference plane. As to this plane, this we called as positive distance and this we called as negative distance as per this axis system. So is this M1 is a distance of A, but is it a minus A value? So the corresponding entry will be, what is moment? Moment is defined as the force multiplied by corresponding distance. But we are not considering the omega square, so we simply write minus quantity, minus M1 R1 A into cos of theta 1. Correct? If you multiply it by the given force with the distance A, that is called as moment. For M2, M2 is here. So what is this distance? Is this distance is positive distance? So is this distance is L1 minus A. Agree? So what is the corresponding force? Is it positive sign? So this one is M2 into R2 into distance L1 minus A multiplied by what? Agree? Then about R3. So from this point to this point, that is for R3, our distance is what? L2. But we have to measure with reference to what? Reference plane. So is this L2 minus of A. And this value will be equals to M3 force. Now two more entries are left. So one entry is for MB1 and other entry is for MB2. RB1 and RB2. What is the distance for RB1 plane? Is it 0? It's 0. And what is the angle? Is theta B1. Theta B1 is correct. And what is the force? Is MB1 into RB1 into cos of, is it theta B1? This term will be sine and this term will be equals to what? Is it 0? Why 0? Because distance is 0. Agree? And then one more entry for RB2. What is the distance between the reference plane and this point? So is that distance will be L2 minus A plus B. Correct? So this one is L2 minus A plus B. And what is the angle? Theta B2. So what is Fx? Fx is MB2 multiplied by RB2 multiplied by cos of theta B2. This one is sine column. And what is this value? Is MB2 multiplied by RB2 multiplied by the distance is L2 minus A plus B multiplied by cos of theta. Is that fine? So I will fill up this column. I have very little space available here, so you can understand this. This one is MB1 and this one is MB2. I have to make one more column. Is that column is for MY? This column is for what? MY. What is the difference between MY and MX? Cos theta 1 will be replaced by what? Sin theta 1. So I have minus M1 into R1 into A into sin of theta 1. Likewise, I can make entry for quantity are known to us. Is M1 is known? Is M2 is known? Is M3 is known? Is R1 is known? R2 is known? R3 is known? Then if they will provide you distance, they will provide you. So this is known. Is it also theta 1, theta 2, theta 3 are known? Theta 1, theta 2, theta 3 are known? Yes. Which one is not known? Is this quantity is not known? This quantity is not known. Distance they have to provide. Then are we able to calculate theta B1 and theta B2? So what they have to provide? They have to provide RB1, RB2. And using distance equation, can we calculate zero distance and L2 minus A plus B distance? So how many unknowns effectively we have? MB1, this unknowns are MB1, MB2, theta B1 and theta B2. Is it fine? Now check the column. In this equation, check M1, R1, A1, sin theta 1 is known. M1. In this figure is the value of M1, M2, M3 is provided. R1, R2, R3 provided. Theta 1, theta 2, theta 3 they are provided. So one by one. In this one, M1, R1, A cos theta 1 is known. M2, R2, L1 minus N cos theta 2 known. This one is known. This one we have MB2 and theta B2, two unknowns. And is summation of mx is 0. Summation of mx is 0. So one equation you can form from this and one equation you can form from this. Two equations. Can we find out in that case the value of MB2 and theta B2? And then we exhaust sigma fx equation. Check my sigma fx equation. Why I am not doing the sigma fx first? Because first quantity is known, second is known, third is known. Here one unknown, third unknown, four unknowns in fx. And here also I have same unknowns. So that is why first you have to solve what? Moment. If you solve moment equation, are we able to calculate NB2 and theta B2? Once we know this equation, we'll come back to the original equation. We put for this one, then is MB1 and theta B1 are only unknown. So what is the first step? MX 0, MY 0. Solve it first, and what do you get? MB2 and theta B2. Once you know that value, you come to fx term and fy term. That's all.